Let's jump into a demo to see BigQuery Omni in action. In the first part, we will look at how Omni provides you the ability to analyze data wherever it resides. In this example, we are looking at a fictitious retailer who has both brick and mortar and online stores. They have their growing e-commerce retail data sitting within GCP in BigQuery. Let's look at the details for this table, and you can see that this is within BigQuery here. They have their in-store and point of sale data sitting in AWS S3 for legacy reasons. Again, let's click through the details of this table, and you can see the source URI points to a file in S3. Into this, it takes me to an S3 bucket where you can see this file. For the purposes of this demo, let's assume I'm an analyst at the retailer. The data silos across AWS and GCP causes challenges for me to look at the data or the business holistically. Typically, it's also hard for me to analyze data sitting in a different cloud like AWS without moving it or copying it. BigQuery Omni greatly simplifies this for me by letting me query the data sitting in AWS through a familiar BigQuery UI and SQL command. Let's take a look at this table that's in AWS and run a simple query against it. You can see that this query is similar to running a query against a table in BigQuery. When I run this query, a request is submitted to Omni clusters in AWS. You can see here the processing location is AWS US East 1. This is a BigQuery Omni region in AWS. Compute runs in AWS, co-located with where the data is in S3. I can grant access to the S3 file through an external connection that is managed by a service account. Once the query is complete, you get the results back in BigQuery. As an analyst, this makes my life simpler as I don't have to rely on other teams to import data. There are not duplicate copies of data that I need to manage, and I can access the data across clouds through a single pane of glass. Now let's move into the second part of the demo and see how Omni helps me combine data across clouds and simplifies cross-cloud analytics. As an analyst, it would be very useful for me to combine the in-store data and the online data, sales data, customer data to analyze trends, get insights that can help tailor our marketing campaigns, loyalty programs, etc. With a new feature called cross-cloud transfer, I can just move the subset of data from AWS to BigQuery for advanced analytics. In the next few steps, I'm going to show you how we can create an aggregated table, starting with BigQuery data, that's online data, combining with S3 in-store data, filtered just to the fields that I need for my consolidated analysis. In the first step here, I'm going to create a new aggregate table, copying from the online transaction table, filter to the fields that are important to me. I can see this aggregate table is created. Preview to see all of the online fields here. I'm going to run a quick query so we can see all of the channels that are in this table here. And you can see that this represents the online channels 3 and 4 in this data set here. Now as the second step, I'm going to run an export query for in-store data in AWS, filtering to the columns I need and the rows I need. Once this query is successfully complete, you can see that the exported data consists of a file. Next step is the load feature, which is a part of the cross-cloud transfer service. This enables you to load data from a set of files into a BigQuery table. This command will create a new table in BigQuery if it does not exist. If the table exists, it will append to it. In this case, since we already have an aggregated table which has the online data, it will append the in-store data to it when we run this query. Once this query is complete, it has successfully loaded the data from AWS S3 into the aggregate table. Run the same aggregate query to look at the channels that we have in this table. And you can see that now it has a consolidated set of channels across online and in-store. And so we have a combined table of online and in-store transactions. Now that the combined data is in BigQuery, it can be joined with other tables in BigQuery. For example, if I want to look at all the customers in California to run a marketing campaign, I can join the aggregate table with the customer table in BigQuery. When I run this query, it will give me the list of all customer IDs that I can use then for my campaign. This is just scratching the surface of cross-cloud analytics. By accessing the consolidated table through tools like Looker, Data Studio, Connected Sheets, we can perform advanced analytics. With that, I'm going to transition over to Meher, who's going to show us the great capabilities of Looker and how it can achieve cross-cloud analytics.